Hey, what's up, everyone? I just cut out the music really suddenly there. I'm sorry. But I hope everyone's having a great Wednesday. I'm super excited for this class today because it'll be the first time that we're touching code already on lesson two. Not only that, but we're going to try to make like the tiniest game. And don't worry if you guys have never coded before. It'll be fine. I'll walk you through, and hopefully the pacing is okay. Just let me know if you have any questions. Um, okay, but first, let's get everyone set up and ready to start working with this code. So, in order to do that, I have a few links in the description. The most important one to download is the GitHub link. So, there is the starter code over here. It'll kind of look like this when you land on it. If you downloaded it before last night, you might want to re-download it because I made a few last minute changes last night. But yes, we're going to use all the logic gate stuff we learned last time, and we're actually going to apply that. So you're going to see how it sort of connects here. And don't be worried that we're already like working in code and working on a game, because I think the best way to learn is probably just to do it. And that way, like once you get your hands dirty with this, like you'll figure it out pretty easily, I think. But yeah, so when you land on this page, don't worry if you don't know how to use GitHub either. You can pretty much just skip over that until like a later lesson. But this is what you want to download. It's called chargeaki.zip. So that's like a little starter file that I wrote for y'all. Yeah, make sure you download that right now. For this lesson, you can actually use any IDE. So if you've coded before, feel free to use whatever you're comfortable in or whatever you just like. If not, I've also provided a link to Sublime Text Editor there in the description below. So you can download that. It's not a full IDE, but I think that's perfectly fine. It's probably a little bit better because it's going to be lightweight and sort of really easy to get into. That's what I have over here at the bottom of my screen if you see it. But yeah. The release was from 4 days ago. Did the changes last night get pushed? Yes. So I actually just updated the release file. So it should be fine. But yes, the release will say 4 days ago because the file is the only thing that I updated. But let me know if that's not the case. It's not a big deal if it's a little bit different. It's just some quality of life things. But yeah, once you download that, download Sublime Text. It's a little text editor. You can use like any text editor, to be honest. Like if you really want, you could use Notepad if you're on Windows or like WordPad if you're on Mac. But I wouldn't suggest it just because if you're first learning, like the highlights really help. And especially if you're going to do anything a little more complicated, it's it's not going to be the greatest to look at. Okay, so hopefully that was enough time for everyone. My eyes are a little stuck here, but that's okay. So what you want to do, you're going to see two files that are really important. You can ignore everything else. There's a little scripts folder and you can just pretend that doesn't exist, but know that that's doing some stuff in the background. Pen and paper works too. If you really just want to like learn the concepts and take notes real quick, but like I really suggest like if you have the time, go ahead and like play with this because the biggest part of like learning to code, I think, is just learning how everything works and like what changing things does. So we're gonna do a lot of that today. It's like experimentation. So let's try that out. Okay, so how do you get this to show up? How do you open it? Well, basically, you'll see a file called chargeaki.html, and you're going to want to open that in your browser. And you can basically pick any browser that you want. I have Chrome over here. I know it's hard to tell because it's a very tiny sliver of the screen right now. And that's not just how it's displaying to you. I actually have it as a very small sliver on my screen. If you have multiple monitors, it helps, but really it doesn't matter. You can have it anywhere you like. You can open it on Internet Explorer if you want to. If your microwave has a browser, you can open it there. Yes, exactly. All right, so now that you have this open in your browser, chargeaki.html, there's another file in there called chargeaki.js, and JS stands for JavaScript. And that's the one that you're going to want to open in Sublime. You can open just the file itself, or if you want, you could just drag the whole folder in, and then it'll show up in the left here as like a little file system. So it'll be easy to see. You can see like exactly what's there. Like this is chargeaki.html. You don't need to worry about the code for it. You just need to like see what's happening. So if you open it in your browser, it's going to look like this, right? This is just a web page. It doesn't matter. We're going to use JavaScript because it's really easy to start in, but the nice part about it is that it looks like a lot of other languages. So it's going to transfer really easily to any C-style languages, or we call them. So that's sort of just the style of language that we're using. But yeah, once you open chargeaki.js, let me actually change it to the main branch so we have a blank file here. You're going to see like a little bit of a skeleton code. And so there are like a few things set up for you already, but everything is mostly just blank. And you'll actually see like there are a lot of things that are grayed out here, right? Yeah, JavaScript has a lot of crazy things that you can do. We're not going to do any of those. There are like some wacky things you can do. It's actually pretty fun. And there are a lot of different ways you can do things in JavaScript. But I'm going to teach you like JavaScript in the most C-ist style way possible. So everything makes sense and it applies to everything else. But the nice part about JavaScript is the setup is really easy. You don't have to compile or build anything. You don't need that IDE. And it's just really easy to jump into. So it's probably a really good place to start off. Any scripting language kind of is, but like, for example, in other ones, like the syntax might be a little different. And syntax is what we refer to as like how a language looks when it's typed. Like sort of the, all the sort of things that make up that language. But yes, you don't have to worry about any of that. Don't worry if like none of that made sense to you. You can just ignore everything I just said. And we're gonna like start from the very beginning. Like I'm gonna emphasize this and I'll probably keep saying it, but you pretty much don't need any coding experience at all. I'm gonna try to walk you through like as if you know nothing. And I know that some of you in chat do have coding experience, and that's really good too. Maybe this is a good refresher, but if not, this will be like pretty chill for you. But yeah, what's the first thing? These things in gray, the reason they're in gray is just because we're using Sublime and it highlights comments in gray. And so you'll see like, this is a way to do a comment. So like 2 slashes. And comments basically don't affect a code, the code that you're doing whatsoever. These basically, like, you could type anything here, and it doesn't matter. Like, none of this will affect, like, the actual code that you're working on. Sorry, I didn't refresh this before, but this is what you'll see when you actually open up the code. But I can type, like, anything I want, right? And nothing in the code will change because of that. And this is really good because it helps you sort of annotate your code. So you remember like what you're trying to do, especially like if you're working on this for multiple days, you can look back, or even if it's like just something that you did, you can remember like, oh, this is why I did that. This is mostly just like a note to yourself, you know? And an easy way to do this in Sublime is like, if you have like a sentence or a line, you can just like highlight it and then do like control slash, and it actually just does it automatically for you. You don't have to learn that. It's going to be different based on what program you're using, but it's like it's a useful thing to know just in case. Another thing, so because what I just showed you, like the 2 slashes, you have to type it like in front of every line, right? Otherwise, like your code will think it's code. Or I guess the computer will think it's code. Instead of doing that, like if you have a lot of multiple lines, you can actually just select the whole thing and then do control slash or command slash if you're on a Mac. And it's mostly just the same thing. Sublime is really useful because it has like a lot of shortcuts like that. And really, like, you'll just learn these with experience, like the more you do them. So yeah, this is a multi-line, like what you just saw. It's just a slash and a star at the beginning, and then a star and a slash just to end things off. You don't need to memorize this. It's not a big deal. Most of the time you will just be using like the 2 slashes as a comment. But that's what everything in gray means. And it's in gray, so you just don't pay too much attention to it. But yeah, comments are very important to yourself and also like for anyone else reading your code. But before we look too deeply into the code, I'm going to show you a demo of like what the actual code is supposed to do and like what will make this sort of skeleton do at the end. And hopefully that's what you'll get it to at the end. So it's basically like a little charge Aki game. I set up like, as I said, it's a really tiny scenario. And I guess you could call it a game. I don't know if that was a little clickbait, but it's a game. You can like, this is like the battery percentage. It represents what my battery percentage is at. You can like move it up or down. And then basically we're gonna add like indicator messages and change the colors. And also once we hit like certain percentages, we want to be able to charge Aki. So you'll see like a lightning bolt for the energy coming in, right? And then you'll also see like a little plug for the actual plugging it in. And yeah, that's basically what it'll look like. We also want to make sure that we take the plug off when we're full, just for battery health. And that's basically what the game will look like. It's a really simple game for now, but it's going to be a really good first game for everyone here. As the lessons go on, we're going to make more complex games. So they'll be like more and more game-like in nature. And then eventually it'll be like a full game. But you got to start somewhere here, right? Yeah, she gets really sad at 0%. That's what I look like when I'm sleeping. But yeah, let me just clear everything here. We're going to go back to what you guys have, which is like just starter code. Whenever you move something, nothing happens, right? And that's how it should be. So this is what it'll look like when you first open it. And let me know if that's not right. Can we add a head padding function? We should. I would like that very much. Okay, so back to Aki, charge Aki.js, right? We just learned about comments, and that's already like your first sort of syntax you're learning in code. So you've learned single line and multi-line. The next really important thing is variables. And you can already see that I've set up some here. Variables are exactly what they sound like. And if any of you have done math in school, it's going to be very much the same thing. So it's kind of like let x equals like 0 or whatever you want it to be. And funnily enough, you can actually do this in JavaScript, but we're not going to use this way to write it. Today, we're going to use var x equals 0, this kind. And so what you're doing is you're telling the computer, hey, I'm going to give you a variable called x. That's what we're going to name it. And the computer sort of makes space for you to give it data. And then equals 0 is us just telling it, hey, the initial value here is 0, right? Like you could also do this. Var x. Now what var x does is you're just telling the computer, okay, make some space for this variable called x, because I'm about to give you information at some point in my program. It doesn't have to be right now, but at some point in my program, we're promising the computer that x is going to be something, right? and the computer just takes our word for it. He sets up like a little bit of space for us to put whatever we want to put inside X, and he just waits until we want to use it. And so like in order to give the computer that information, somewhere else in our code we just write X equals 0, or like X equals whatever we want it to be. This can be a string, which is just like words. It could really be anything. It can be anything we want, because in JavaScript there are no types. We're going to learn data types in a different lesson, but just know var means variable. Okay, so as I was saying, we already have a bunch of variables here, right? But what do they do? Well, good thing there are comments so you can tell what they do. But if these weren't here, a really good way to tell what variables are is to actually just change them and see what happens, right? First of all, I guess the most important part is look at the name. The name, and you probably want to do this with your variable names as well. Your name should correspond to sort of what the variable does, right? So you don't want to name something like variable fruit and then give it like an egg, you know? So generally we want to name things in a way that makes sense to whoever's reading it, not just the computer, because the computer doesn't care about what name you give it. You could put anything here, and as long as you use the same thing, the computer doesn't care. He's smart. But people need this, you know? I need this. And so for our battery, what could battery be? Well, it's probably this, right? You can already see that it's starting at 50% when it first starts. And so this looks like a pretty good candidate. The way we can check that is, what if we set this to something else? Let's set this to 0 and then refresh the page. I just use Control R. You can refresh it however you normally refresh a browser page. Because the nice thing about this is that you should already know how to use a browser, right? If you're on YouTube here watching, I assume you browse the web at some point. So yeah, we changed it to 0, and look, that is the thing that changed. And you'll notice like this also changed. This little input field, it changed to 0 as well, right? So we can probably conclude that like these two are linked. They don't necessarily have to be, but that's sort of our intuition there, right? That's sort of what it's telling us. So we can set this back to 50. I would suggest, like, while you guys are doing this, like, play around with these variables just to see like what they actually do. Okay, moving on to color. Color seems pretty obvious, right? Color is just an English word. And we have it as red. So the 3 colors that I have set up for you, because this isn't normally a JavaScript thing, it's just hidden away in other code, are red, yellow, and green. So you can do red, you can do yellow, which changes this once I refresh it, and you can also do green. And those are sort of the only 3 colors that are available to you here. Yeah, that's just something I'll tell you right now. But yeah, you can change those, and you can see, yeah, it changes the color of the indicator, right? So that's pretty simple so far. Yes, that explains why blue didn't work. I guess I don't need to show you, but I actually just have the hex colors defined over here. And that's the reason you can actually use those 3 colors. If you guys add more here as like maybe a bonus question, you can actually use like other colors, but you really don't need to worry about that. That's not something, it's like over and beyond this lesson, you know? Okay, so the next 2 things are a little bit different. Variable plugged in equals false. So what does that mean? Plugged in indicates whether Aki is connected to the charging port or not. So what happens when we turn it to true and then refresh the page? It plugs us in, right? It shows us this little plug emoji. And that sort of indicates to us what plugged in is doing. So plugged in is linked to this plug. Simple enough, right? We can change it back to false just so we're only changing like one thing at a time. Because that way we know like if we change like 2 of these things, like we won't be able to tell like what changed what sometimes, you know? Like if we change both of these to true, we would have just seen like both of these pop up and we wouldn't know like which one is corresponding to which. We do have sort of a semblance of a clue because of the name, but in code, you really want to change like one thing at a time. It's really similar to like science experiments where you want to like have one thing change as like the control, you know? It just makes it easier for yourself. You'll notice that like at the end of all the lines, there's a semicolon. That's basically just telling the computer that, hey, this line is finished. This is like one command, you know? And the funny thing about JavaScript is you don't actually need to put the semicolon, but we're going to use the semicolon. It's really good practice because some languages aren't as lenient. And it's not always going to be the case that like you don't have to put a semicolon. Sometimes it's not optional. And so in order to learn this to extend like every language, we're going to do it in a way that fits most languages, if that makes sense. So put it, JavaScript won't yell at you or give you errors if you don't put it sometimes, but you should put it. And the reason that you sort of want to put it is because JavaScript spaces and lines don't really matter. Like I could put this all on one line. Like if I get rid of this comment and put this all on like one line, JavaScript knows that these two are different commands. And that's really what the semicolon is doing. It's telling us that, or it's telling the computer that, hey, this is a different command. Don't confuse it with this one. Don't mix them up, you know? Yes, the semicolon helps to keep things clear. It helps your head too. And so does like splitting these up into lines. Like if you wanted to, you could really just compress all of the code into one line. The computer can read it and then it doesn't care as long as it does what you're telling it to do. But for any human reading it, it's going to be awful. So poor them. We're going to be nice to the humans, the Miss and Mr. humans who are reading this. So we're going to put the semicolons in. So the next thing is charging. We see that the comment says whether Aki is currently charging or not. And that sounds pretty obvious. I did show you a little bit of it. If we turn it to true, it just shows you the little lightning bolt. So normally like in the real world, if something is plugged in, it's usually charging, but not necessarily, right? Like you're assuming like the outlet has power, the charging cable works. And so we just sort of separated these things out here. The next one is var indicator, and it has like two little apostrophes here, like quotation marks. What does this mean? It means it's like a word. It's called a string, but you can basically type anything here. Like you can type hello, and anything you type in here will basically just let you type anything you want. And you'll see that it actually shows up at the bottom here as the indicator message, right? Cool. With JavaScript, and with most languages actually, you can either use double or single quotes. It doesn't really matter. There are some times when it matters, but just know that you can use either of them right now. Well, actually, I guess I could tell you when it matters. Like, for example, if you have two, or the surrounding things as like single quotation marks, then like inside, if you go like, hello, test, then you can actually type little quotes in your actual string. Because like if you try to do this with single quotation marks, the code's gonna get confused. Like you can tell that Sublime is even getting confused. Like what are you telling it? Like it's thinking that this is a string, and then this is, it doesn't know what this is. So it's very confusing. This will break it. But what you can also do to combat that is if you do a backslash, this actually tells the code, don't take this as a command. Take this as just this character. And so you'll actually be able to see that. So we'll learn more about that when we do data types. You don't need to worry too much about that right now, but it's just something fun to be aware of. So we're going to get rid of all of that right now. Cool. So we're back to 0. I've reset everything to the variables initial values that we had once you download the code. Yeah, sometimes we plug things in to transfer data. This isn't one of those kind of plugs. This is a power plug. But we can use it for a lot of different things. But these two are basically just telling us whether or not something is happening. Now, how do we use this? Okay, well, actually, before we do that, I want to show you guys a little trick to sort of see what your code is doing, I guess. So in your browser, you can actually open up something called the console. You can do this. So a lot of modern browsers use Control-Shift-I. You can also use Control-Shift-J. In Chrome, it lets you do both. Or you can tap like the little 3 dots at the top or whatever your settings are and go to like More Tools, Developer Tools, and you can open this. And this is like a really useful tool. Like you can actually code in here if you really want to, right? And you can actually see what code like the page is running. So this is like chargeaki.html and like chargeaki.js, which is like exactly what we see in our Sublime. You normally don't want to look at it through here, but it's available to you if you want it. It's just there so you know that everything is sort of linked there. Yes, you have to save the file in the code and then refresh your page. Yeah, there you go. Good job. Thanks for answering that, Dylan. So yeah, you can actually see like you can set things in here. Don't worry about the undefined. This is just giving you an output object, but you don't need to really worry about that. One really useful function that JavaScript lets you do is console.log. And what console.log does is it lets you print something out. Like you can print out hi, and then it'll say it back at you, right? And now that we've set variable x as 0, you can also say console.log x. And then since we set x, the computer already knows what x is. It stored it away in its brain. And if we do this, it actually tells us x is 0. You can ignore the undefined because this is something else. But it's saying x is 0 here. And you can like change x into like something else, right? So now x is something else. And you can like print it out again. And it prints out something else. So really we're just telling the computer, this is what x means. Now say it back to me. Yeah, I should have mentioned, remember to save your code before refreshing the file. Anyway, you can clear the console using this little scary button here. It's like a big block sign. Or you can use Control L or Command L if you're on a Mac. Either way works. And what's so good about logging to the console? So this is actually really useful for telling what your code is actually doing at different times in the code. The reason we have all of these as variables is because our code is going to be changing them. So they're going to take the data in them and change them later on throughout the code, right? And they might change into several different things at like several different times. And so what this does, console.log, is basically just helping us know like what the computer thinks each variable is at a single time. Or like when a computer reaches this part of the code, you know, so you can print like test or like anything you want really, and then it'll show it in the console. And like this can be a string. You can also put any of the variables in here that are already defined. So if I say console.log battery, what do you guys think it's going to print over here? So we told the computer that var battery equals 50, right? So it's going to print 50. Now, what if we change what battery stands for in the middle of the code? battery equals 100. So the next time you use battery, you don't need to call it variable anymore because the computer already stored away space for it. It's already reserved the space. So next time you can just refer to it as battery, right? Because the variable part is really telling the computer, hey, make some space for this. But since it already has space, we can just say battery equals 100. And now it's telling us it's 100. If we do console.log right before it changes to 100, what do you think it'll be? It's going to be 50, right? So it's 50 first, and then the computer does this reassignment. It says battery is 100. Okay, got it. And then it changes it to 100. But this is a little bit confusing for people to read, right? Like these are just random numbers. If someone comes to your code and they see this, they're like, what the heck is going on? And so a really good way to combat that is to just add like text to your console lines. So if you say battery is, just so like you know what's going on, right? It tells you like exactly what is happening. It prints out the string you want plus like the value of battery, which is really nice. And you can actually keep doing this. So you can separate different elements by commas. So you can say color is, and then the next one you can use as color, right? And we can just copy this over because we're saying the same thing. And maybe we can change the color to green now, right? So what is this actually going to show? You'll notice that the code ends at 100%, right? Like this is the last time we change battery. And so what we do, or what happens when we refresh, is that the computer does all of this and then stops. And that means color is going to be, whoops, I didn't put equal, sorry. That's a weird thing about JavaScript. It doesn't yell at you about errors. It just lets you do whatever you want, which is kind of weird, but it's also a little bit helpful. So it's not too intimidating at the very start. But yeah, so in this code, what's happening is like our battery and color start at 50 and red respectively, right? But later on in the code, we're actually changing it to 100 for battery and green for color. And we can tell that because at the beginning, it tells you battery is this, 50, and color is this, which is the hex code that red and green represent. So this is red and this is green. So it's not very nice looking for you to read, but this is how the computer sets the color. All right, so that makes sense, right? And you can put whatever you want here. So like if you put 1 here and like 2 here, that really helps you differentiate what's happening when. And this is really useful for when your code gets more and more complicated, because then you can tell like when things are happening in your code, and you can like track things down to exactly where in the code it's happening, right? So get into the habit of like using these lines, get into the habit of changing one thing at a time, and get into the habit of sort of asking what your code is doing instead of wondering why it's not doing what it's supposed to. Those are like little tidbits that are useful across like all programming. Okay, so now that we know how to do those, how do we actually make this do the things we want to do? How do we make it like that game so that it does something when we change the values here? Well, I added a bunch of comments here in like a question style format that we can start going through. And I've written this in a way that hopefully if you do miss this lesson live or you don't feel like watching the VOD, that you can follow along. But yeah, let's just go through this. So if statements are what we're going to use for this first question or this first block of questions. And so what an if statement looks like, I'll show you guys here, is if, so there are like 2 curly braces and also 2 round brackets. So we're going to break this down. This is going to look a little bit different from what we just did. But what this is saying to the computer is that if is the command. Remember, we had variable as the command here, var. Now if is the command. So if, and then we're going to put a condition here. We're going to put a condition here, and then down here, we're going to put an action, right? So this isn't going to run because condition and action aren't actual things here. But in plain English, this is like, if a certain scenario happens, then do this, right? That's basically what we're trying to do with an if statement. And you can kind of think of it as just plain English. It's when you want something to happen and what you want to happen when that thing happens, you know? So for example, if we look at the first question here, we'll see it says, since I'm battery powered, we need to know when to charge me. So we're going to use an if statement. And if you remember, plugged in is what determines whether or not like I'm plugged in, right? That seems pretty self-explanatory. When she has no power. So this is the condition part of it. We want to do this, plug Aki in when she has no power, right? So this is the action. Try action. And then this is the condition, right? So if you remember, this is if condition, then action. And we're going to put this in a little comment block so it doesn't actually affect the rest of our program. Okay, so for number one, what does this actually mean? So we can start with the condition. So when I have no power, what does that mean? Well, what indicates my power level right now? It's battery, right? So something has no power when its battery is 0. So if battery equals 0, and you'll see that this is 2 equals, and the reason we do that is because equal already means something to the computer. Like whenever the computer sees like equal, it thinks, oh, I'm about to get some data that I need to store into here. So if I were to say battery equals 0, the computer's actually going to try to assign battery 0 here, right? So it's actually going to think that that's what we mean. And that's really not what we want it to do. We want it to compare battery with 0, right? You can put any number here, and it's basically just comparing like the two of them. You can compare battery to color, and this will never be true because battery will never be the same value as color. JS does things, I think it's special with 3 equal signs. What Shad the Hedgehog 16 is referring to here is that a lot of the times in JavaScript, you can actually compare things using 3 equal signs. And that's because JavaScript operates in objects, and it's trying to compare like what type it is. So it's like a stronger version of the equal comparator. But you don't need to worry about that. We're going to use equal equals because that's what most sane languages use. And that's really all we're going to need for this. So the condition, when she has no power, is if battery equals 0. Does that make sense to everyone so far? Is everyone following along? Good. So we have the condition down, right? And the way we can check that actually before we do the action, because we want to be sure that this is doing what we want to do already. We want to only change one thing at a time, remember? So let's actually print out battery is 0, right? Or actually let's print battery is out of power or something like that. And so you can see like it's at 50 right now when it starts. So battery isn't 0. What happens if we change it to 0? Then it prints out battery is out of power. Good. That makes sense, right? Everything hopefully makes sense so far. Don't forget the semicolon. We can get lazy about it, but you guys got to keep me honest. If I do get lazy about it, just spam it in chat. I don't know. But yeah, so we know that this condition is working. So it's actually activating exactly when we want it, which is perfect. The next thing is to do the action, right? So what's the action? The action is plugging Aki in. If Aki's not plugged in, we already know that plugged in is false. That's where it starts, right? So what we actually want to do, and remember, like we were playing around with this, plugged in equals true puts the plug in, right? So what we want to do is put that here. If plugged in equals true, or I mean, if battery equals 0, then plugged in equals true. Perfect. So we can try that. Save your code and then refresh it in here. And then we're going to move it down to 0. Ready? Enter. And then you can see, yay, it plugs it in. I took out the command line log. So it's not printing it out anymore, but it's doing exactly what we expected it to do. It's putting the plug in, right? Yeah, that's what we want. And that's really all there is to if statements. That's like the basis of most programming. That's how simple it is. You're already coding. Moving on to the next thing, like it gets a little bit more complicated, but like at its core, that's really the idea behind programming. It's like, just ask the computer to do things and tell it when you want to do those things, right? And feed it data on which to do those things. So the second question here is, let's make sure I'm charging when I'm plugged in. So right now you can see that our code is already plugging me in, but there's no power. There's no power here. Remember that little lightning symbol? It's gone. I'm sad. And so how do we do that? Okay, let's identify the condition, right? When she's plugged in, that's the condition. We can write that. When she's plugged in. What's the action here? The action is charge me, right? Aki is charging. I didn't word this in a very good way, but the action is charge Aki. And then this one was plug Aki in. All right. So now that we sort of split this up into an action and condition, we just translate it to something that the computer knows how to work with, right? So if we have our if statement here, and you'll notice that I'm like tabbing this out or like adding spaces at the beginning. This is just for readability. JavaScript really doesn't care. The computer doesn't care if you put these. This is for your benefit. Like, this is so you know, like, this is one line of code, right? For statements, like if statements and if blocks, we don't actually put a semicolon at the end. That's a little bit of an exception there. So you just have to bear with that. But this curly brace means the end of a statement. Anything within the curly braces means that the computer will do all those actions while this condition is true, right? Or when this condition is true. Like, I could keep adding things to here, and then it'll do all of these. So if I actually run that, when Aki's battery is 0, it actually prints both of them. And I could keep going. I could put any number of things within these curly braces. But these curly braces are how the computer tells all of the actions that it has to do. It's telling it, hey, this is a list of things that you need to do. And no matter how big the list is, the computer doesn't care. It just does all of them. Anything in these braces. We're putting these tabs just so we can read what's inside them. But yes, that's what those mean. Okay, so back to this. We're going to uncomment this again. Oh, and let's put it at 2 so we know what we're doing, what we're working with. So 2, we identified the condition is when she's plugged in. So we already know when she's plugged in, that means plugged in equals true, right? So let's check if plugged in equals true, right? So you're checking plugged in versus true is basically what this means. Which language is this? This is JavaScript. It's going to look really familiar to you because it's C-styled. It's going to look like a lot of different languages that are popular now. So it's like a really good way for us to learn right now. I have a little bit of a delay on the stream. That's the nature of the internet. So if I miss any questions or they come a little later, just feel free to spam it at me. Or hopefully Jay or someone else can answer it in the chat. But yeah, if plugged in equals true. Now, another way that we can actually write this is, since we know that if plugged in is true, right, then this will be true equals true, which is true. If not, if it's false, then it'll be false. It'll be comparing false and true, which is false. So since plugged in is already telling us that, we can actually just say if plugged in. We don't even need to compare it to anything because it's already telling us true or false, right? That's all the computer needs to know. We don't need to compare plugged in to true or false because it can only be true or false. So if plugged in is the better way to write this. So we can say that. So that's our condition. If plugged in, what's our action? Charge Aki. How do we charge Aki again? Well, let's look at our variables. We had plugged in, which is telling us whether Aki is connected to the charging port or not. And we also have is charging. Speaking is hard. Is charging, which is telling us whether Aki is currently charging or not, right? So this is probably the one we want. And the way that we can tell that, again, is we can just, here, let's refresh everything. We can change this and we can check what it does in our code. Yeah, it charges us. It gives us a little lightning bolt. That's what we want. So change this back and then we can actually move this down here. Is charging equals true, right? And now when we refresh everything after we save and then we put everything to 0, yay, we are plugged in and charging, right? That's awesome. That's what we want. And so you'll notice that like we never change these back to false anywhere in our code, right? So they start false, plugged in and is charging, they start false. And then we turn them true in the code, but then we never change them back. So that means once Aki is charging, Aki's just always going to be charging. Even if she's at 100, she's never going to not charge, right? We're going to fix that. Yeah, the font for these is going to be very much the same for any language you're using because it depends on what program you're typing it in. It's just your text editor. The highlights are going to look really similar too because JavaScript and C+ look really similar. And that's because they're both C-style languages. They're both based on C, which is another language. And a lot of modern languages are based on C. It's actually a very popular language style, I guess. Well, C is also a popular language, but C-style languages are very popular. So anything you see here today can be applied to any other C-style language. Yeah, anything like you can see Java, C#, C++, Go. It doesn't matter. All of these will mostly look the same to you. They'll have different quirks in how they do things in the language, and some of the words will look a little bit different, or they'll be called different things, but it will very much look familiar to you, which is pretty amazing, because that's what I was saying in like my first stream, right? Knowing languages, it doesn't mean too much. It's more about knowing like how to problem solve and how to write code in general. And that's what learning coding is, not like I'm going to learn JavaScript, I'm going to learn C++. And that's obviously important. Like the languages have their own intricacies, but the most important part is to learn how to give commands to the computer and how to get it to do what it wants or what you want to do, which is pretty cool. And that's why like you could do this in any programming language you want. I picked JavaScript for this because I thought it would be a really good place to start for everyone. But if you wanted to, you could follow along in whatever language you're comfortable with. All of my lessons will be like that. I probably won't stick to JavaScript for all of the lessons, but yeah, that's what it's gonna be like. But yeah, so nice. We've done part 1, right? And now we wanna be able to take the plug off and stop charging. Well, actually first, let's stop charging first, because we don't necessarily have to unplug to stop charging, right? So the second part of question 2 is, for my battery health, we need to make sure that I don't keep charging when my battery is already 100, right? And you'll notice that with this code, you can't go past 100. I've already constrained it for you. You can't go to negative numbers. It's minimum 0, maximum 100. So it's already constrained here. In your own code, if you're starting from scratch, you'll normally need to think about cases like that, like edge cases, because you need to determine like what users can actually input. But for today, you don't need to worry about it. Today, we're just gonna be very straightforward. We're only doing like if statements. Everything else is just bells and whistles, you know? Cool. So we're gonna refresh this, just reset everything. Let's do the same thing. We're gonna identify the action and the condition. So let's do the condition first, because it starts off like that, right? So we can start doing the if block here. So what's the condition here? When my battery is already 100. That's the condition, right? Condition. We'll tag it. You don't normally have to write this. Actually, like I don't think anyone writes this, but I'm just showing you what is going on. This is what's happening. So when my battery is already 100, right? That means if battery, we've seen very similar things before. Like this was when she has no power, which is the same way as saying when her battery is 0, right? It's just taking English and translating it to a way that the computer knows what to do with it. So now, when her battery is 100, well, these two look pretty similar, don't they? So when her battery is 0, we did battery equals 0 to compare battery and 0, right? So now, when we want to compare battery with 100, we just do the same thing. Battery equals 100. That's not how you spell battery. That's how you spell battery. Okay. So we can check this the same way if we really want to. I'm not going to do this every time because these are pretty simple statements. You can check it yourself just to make sure. Battery is, and then you can put in the battery variable and it'll tell you if we move to 100, battery is 100. Nice. And another way to actually do this is instead of doing it within the condition, since this runs, all this code runs every time, anytime you press one of these arrow keys or anytime you change this value, you can actually just put this anywhere, right? We'll put this at the very bottom. And what this does is like, it actually tells you in real time as you're clicking it, what the battery level actually is. Because you're no longer doing it within the if statement, right? You're doing it outside. So it's gonna list every single battery level for you as you're doing it. Can you use if statements for developing websites? Yeah, you can. That's actually exactly what JavaScript is for. It's built as a web language to power pages, like web pages. Like any modern site that you go to is just using a combination of HTML, which is this physical page here, JavaScript, which is all of the things in the background, like all of the code in the background running that's making this do what it's doing, and CSS, which is, if you go dig into the scripts folder, you can actually see the CSS. Don't worry about this because we're never going to use it, or at least not now. And what CSS does is actually, it's giving us the styles of the page. So it's sort of like a skin, if you want to think about it that way. If I remove all this, like, it'll just go back to like a very flat page. It's going to do like one thing per line. It's going to get rid of like all the styling elements and just everything. But this style is mostly just to like center it here and to make this look a little prettier. Don't worry about styles, but that's there. But yes, you can use if statements for developing websites. That's actually, it's a pretty common use case. You do need if cases for a lot of websites, unless your website is like literally flat and does nothing. Then you can omit JavaScript. You can just have a plain HTML page. But that also means your website won't do too much. If you need it to display information, you can use pure HTML. If you want it to do anything fun, that's where JavaScript comes in. But yeah, back to this. Now that we have this, we can actually keep this, right? Like, this will actually help us see like what is happening. We don't have to keep this because like this is obviously already reflecting what battery equals. But you can keep this if you really want to. So we have our condition now, right? We have our if statement. Now, what is our action? Did we already find the action? We did not. The action is make sure Aki doesn't keep charging, right? In other words, the action is stop charging Aki when her battery is 100. That's another way to think about it, right? Yeah, programming is just rewording things in logical ways. Finding patterns and finding equivalencies here. So how do we stop charging Aki? Well, to start charging Aki, we did is charging equals true. So that means we can just do is charging equals false. It's that simple. We can test it too. We should test it, actually. Every time we write anything in code, we should test it. Because the worst thing in the world is if you write a bunch of things and it doesn't work for some reason or something is wrong. And then you have all this code that you have to dig through and you have to see, oh, did I mistype something? Did I set a value wrong? You have to dig through all of it, right? If you do things one at a time, you don't need to do that. You already know what's wrong. You know it has to be the last thing you did, right? You know it has to be this. So yeah, we refresh this and we set the battery to 0. Okay, so we already know that this was going to happen because this is what our previous code did with question 1 and 2, right? Now, what happens if we move it to 100? Let's do 100. Bam. The charge is gone. So Aki is at 100 and she's no longer charging, right? But only at 100. She only doesn't charge when it's at 100 because the plug is still always in. And that's what we wanted it to do for now. That was actually 2, 2. I put 3, but it was 2, 2. So it's like this, right? Nice. But we can actually combine this, can't we? We can, because we're manipulating is charging. So we want it to make sure that if, well, actually, how do I put this? We want to make sure that Aki is only sort of plugged in and charging when her battery is like 0. So another way that we can do this is if plugged in. Sorry, I'm just reading the chat real quick. Your plug disappeared on that bit. You might have mistyped that somewhere. Yeah, it's good that we're like building this up as we go because then you know like exactly what's wrong or like exactly which line could be wrong. And then you could pinpoint like what's wrong. But yeah, where were we for this? Let's see. So we can actually do 3 here, right? Take off the plug when Aki is at full power. We don't need to combine it yet. I'll save that for a little later. So we'll do another if statement here, right? So using an else if statement. So this is something else. If statements include else if statements. So they're going to be a little bit different. Let me just, sorry, I'm adjusting a few things on my side here. Okay, so we don't need to have Aki plugged in all the time, right? You've combined all the things, perfect. Yeah, we're gonna optimize this in just a little bit. I'm trying to decide what the best way, what the best order to do this in would be, in a way that makes sense. But yeah, we could do this. So we stop charging Aki when she's at 100, right? So now we don't need to keep Aki plugged in all the time, right? We're gonna take the plug off when we're at full power. And so let's start with just an if statement. We're not gonna do the else if statement yet. We're gonna change our statement into an else if statement soon. So let's find the condition here. When Aki is at full power, right? That's the condition. And I'm gonna stop typing this eventually, but I'm typing it just so you guys know. So when Aki is at full power, which also means that battery is 100, right? So if battery, oh my gosh, equals 100. So we're comparing battery and 100 again. We take off the plug, which means action is take off the plug. And we already know that taking off the plug means that plugged in equals false. There you go. Facts, false. That's what I mean. And so we can test this out. So at 0, we're plugged in, right? And then if battery is 100, it takes the plug off and we stop charging. And then it doesn't trigger again unless we go to 0 again, right? That seems kind of reasonable. Now, how can we write this with an else if statement? Yeah, I'll get the word battery correct sometime. I swear I know how to spell battery. I don't know why I'm typing it wrong today. Like, surely I have it enough times in this document that at least if I didn't know, I would be able to reference it. But I guess that's just not the case. All right. So what's another way we can do this? We can sort of group all of these lines, right, in a more logical way. Because right now we have like 4 if statements, and 3 of them already have to do with battery. Like, one thing that we could do here is combine these 2, right? So if battery equals 100, is charging equals false and plugged in equals false, right? Like, these 2 conditions are exactly the same. These if statements are exactly the same. And we know that everything within the curly braces are actions that the computer is going to do. So we don't need to split these. We can have these all as one. We can take out the question numbers too, because now we're sort of going off the books a little bit. So this code does the exact same thing as what we just had, right? But in fewer statements. And this is really important because it helps you simplify how you're thinking, and it helps the computer simplify how much it has to do. Yeah, it's like stepping in a campfire in Minecraft. No. I wish fire didn't exist. But yeah, helping the computer optimize is really good for it, especially when it starts doing more complex things, because these little things all add up, right? And it also helps us reduce our mistakes, because if we think about it in like a bunch of different ways, and we're not combining all our logic, then it's really easy to make mistakes, right? I swear I know how to spell battery. I've never gotten it wrong before. I don't know what happened. That's what happens when you're low on power, kids. There are campfires in Minecraft. And if you step on them, you'll have a bad time, as I've learned. But someone put it on the ground where I was jumping, so I like to think that it wasn't my fault. But anyway, look, we just saved ourselves so many lines by combining these two. And this way, actually, it saves the computer a lot of effort too, because before, when we had it this way, it had to check, oh, is battery equal to 100? And then it does this, and then it checks again, oh, is battery equal 100? When we know, like, battery is not going to be changing between these, right? So since it's not changing, we just keep it the same. Oh, I just got rid of everything, but it's okay. We can just keep it the same. I'm going to keep plugged in at the top just so it corresponds to this one a little bit more. But there we go. Yay. We got to get rid of an entire if block just by combining these two. You know that Yandere dev was ridiculed for his code's incredible lack of optimization? Yeah. It's a really easy sort of mistake to make when you're first starting to code, because you're sort of thinking in terms of like a very sequential way of like, I want this to happen, I want this to happen, but a computer just does all of them at the same time. So you want to find the best ways, and that's where like looking for patterns is really useful in coding, is like looking for patterns you can group things in to do like the commands in the most efficient way possible, to let the computer do what it needs to do in the most efficient way possible. Yeah, it does get really annoying to read. Like, obviously this is a lot clearer, even to you, and like obviously to the computer as well. Like, honestly, the first way we did it wouldn't be that big of a deal to a computer, because the computer does this so fast. It doesn't care if it has to do like one more if statement, right? If it needs to compute that. But as we get into like more and more code, where the computer needs to do more and more, then that's when it actually matters, because all of these sort of optimizations add up. And if you're doing something that's like structured in a bad way the first time, then the computer's gonna have to do all this extra work when it could be doing like a lot less, right? Yeah, why waste time type block condition when few condition do trick? But yes, that's basically how to do it. So we just did this. We took off the plug when the battery is 100%. But we still have two different battery statements, right? So the computer is checking here, is battery 0? And then if battery is 0, it sets it to true, right? But here again, it's checking if battery is 100. We already know that if battery is 0, it's obviously not 100, right? So if this is true, does the computer really need to check this again? No, right? Because we know that like if battery is 0, then battery is obviously not 100. So we can sort of combine these two into something called an else if statement. And what that means is basically we add else here. You can type this like this too. Most people like to put it on one line, so you know that like this block is one single statement. But you don't have to. You can write it however you want. This is just like sort of the conventional way to do it. So now we have, if battery is 0, the computer will do this, and then it won't check any of this. It'll just skip straight past, which is what we want, because we don't want the computer to do all this extra work. He's a hard worker. He doesn't need all that. There are better uses for his time. And that just makes our code that much more efficient, right? So we basically just eliminated another if statement, if that's how you want to think about it, right? Because before when we had it like this, it always checks if battery is 0. It always checks if battery is 100. But we don't need that. We just need it to check if battery is 0. And then if it is 0, we know that it can't be 100. So we say, okay, you can take the rest of the day off. Go on to the next thing, right? And that's kind of how it works. Okay. So now let's move on to 4. So now that we're taking the plug off, as soon as I hit 100%, so we know that Aki will always be charging when she's plugged in, right? Let's optimize our code a little bit more. Remember how we wrote this condition before, if plugged in equals true, right? We can optimize this a little bit further. So if plugged in, charging equals true. Well, that means charging will always equal plugged in, right? Because if plugging is true, then it does this. If plugging is false, it doesn't do this, right? And so another way to write this is just to remove the if statement altogether and do is charging equals plugged in. So this is telling the computer whenever Aki is charging, she's plugged in, right? This doesn't work completely the other way around. Does anyone know why? You sort of have to think of it in the context of this. And that's because the plug doesn't depend on whether or not we're charging. Charging depends on whether or not the plug is plugged in, right? That's what we're stating here. Yep, so now it's only 1 line. We've optimized it that way. Right? So it still does the same thing. You can move it up or down. When it reaches 0, it plugs in Aki. It charges Aki. All the way up until 100, where it takes off the plug and it doesn't charge anymore, right? And it won't do it until we hit 0 again. And that's what we want. There we go. Now we've optimized this code to do that, right? Does that make sense to everyone so far? I hope I'm not going too fast or anything. If any of my explanations don't make sense, let me know. Is it bad practice to stack if statements? Like to add else if? Generally, no. It depends on what you're doing. Else if statements are always better than multiple if statements if you can use them, if applicable. Or do you mean if it's bad to write it this way? Yeah, let me know if you want me to go over any of these again, or go deeper into the explanation. I can find a different way to say things, hopefully. Does this mean you can get rid of the is charging equals false? Yes, it does, because is charging always equals plugged in. And you can test it to make sure that that's true. Like you could check 0, you check 100, you check to 0 again. There you go. Oh, like having 3 else if statements under each other? It depends. It really depends on what your conditions are. And this is going to lead into our else statements, which is sort of this next block here. Or I can actually show it off here. So far we have an if statement. This is else if battery equals 100, right? Actually, I can't show it off here. I'll show it off a little later. Another way you could actually do it too is like, you can obviously have like if statements within each other, right? If something happens, you can do stuff. And then if something else happens, you can keep doing stuff. So it really depends on like what you're trying to do. It's not bad practice inherently to stack else if statements, if that's what you mean, like to just use a bunch of else if statements. No, that's pretty normal coding practice. But there are definitely ways to use it where you shouldn't, but they're not inherently bad, if that's what your question is. What was the question? With the same if way, can we change the icon of the battery to turn into another icon? Or if it's below 50%, turn the battery on orange. Yeah, that's going to be our next thing, actually. Or it will be soon. It's like down here. Yeah, that's question 6. We're going to get to the color changing soon. We're going to do a little bit more practice with the if else that way. And then hopefully it makes a little bit more sense to everyone. Because I think the more you do these, the more your mind will sort of recognize what they do. Right. So yeah, if you have any problems with this, feel free also. I have the Discord link down in the description below. If you want to join that for any like specific help with your own code after, I could definitely answer questions too. If you have any questions about this right now, feel free to add them into the chat. But if you also want more personalized help, I can give that to you after. But yeah. Shall we move on to the next question here? Awesome. Okay. So I'm gonna take that as a yes. Oh, I guess another way to do this also is, instead of saying, like, if you really want to practice if statements, you can actually do it the opposite way and try that. Like in my sample solution, I also did the opposite of this just to show you like what you can do. Like this is just one solution that you can use to accomplish this. Like for example, you could also flip it the other way, like do if battery does not equal 100, right? Or does not equal 0. And you can do any number of combinations of these as long as your logic is correct. Like as long as you like work it out step by step of like when the conditions actually trigger and when the actions happen, then you can write any number of different things here. Like there are multiple solutions to this, which is kind of interesting. You can find many different ways to do this using just the things that I taught you. Question, will there be a series on game dev kind of programming? Sorry if that was already answered. Yeah, we're gonna work our way up to that. I think that's probably the final goal for this. I'm gonna, as we learn more programming, I'm gonna sort of go deeper and deeper into game dev, if that's what everyone has an interest in. I think it's a really good way to learn programming too, just like general purpose programming. So like for any of you new people here, I do have a background in game dev. And so I can do any number of things from like, we can start learning how to use game engines. We can start learning about like game loops. And we're basically just starting from like 0 right now. So we're going to work our way up there, you know? And like, it doesn't necessarily have to be all programming things. Like I think someone suggested like game dev portfolio review, or even doing like a community, game dev game, or like a game jam or something. So those are coming up soon. Those are coming up soon. But for now, we're starting from like the bare basics, starting from the beginning of programming. Yeah, game jams would be really fun. You've never tried to make a program with only ifs? Yeah, for sure. Programming is like a combination of like ifs and like a lot of other things. Like ifs are one of the most important building blocks in programming. Next week we're going to learn about loops, but loops and ifs are all really important. So this is just starting off. So hopefully this is all making sense to everyone. We can start moving on to the next thing. I'm not going to show every single solution on here, but if you do have a different solution, I can help you, like, if you're having trouble with it, I can help you with it in the Discord. Like if you send me parts of your code, I'll just tell you like where you can look or like what you can do to sort of debug it. Debug is what it means when you're sort of trying to fix your code. Because things that are wrong with your code are called bugs. I know that everyone's really new here, so there are going to be a lot of terms like that, but they all are pretty intuitive. Don't worry. You're going to hear a lot of different terms. But yeah, let's move on to the next thing. We have it working the way we want right now. This solution is actually a little bit different than the one I posted in the GitHub. So you can take a look at both of these. But yeah, let's do it. All right, so we did 4 already. I just didn't put it in the right place. But we can get rid of this reference here too. And that's another thing, like after you finish your code, you can start cleaning things up, like get rid of all the console.logs, get rid of things you don't need. Sometimes you want to keep comments, definitely keep comments, but for things that you don't need anymore in the show your work kind of things, we can get rid of them. Just make sure everything is like cleaned up and nice to look at. Okay, so this next part, we're going to introduce a few more things like comparators, right? Oh, before I forget, actually, oh, actually, no, that's okay. We can just go into this. For these kind of conditions, a lot of them you can actually, if you remember our lesson on logic gates, you can use like and to like add different conditions to here, right? So like you can also set, so you can say if battery equals 0 and is not charging, right? So you might recognize these from last lesson where we learned about and, or, and not gates, right? Hopefully this is making sense to you. I just made a really big jump here. But probably a better way to learn this is actually, let's redo some of this to use logic gates, right? So if you'll remember, logic gates are not, which is just an exclamation mark, or, and, right? So we can make it so that if Aki is not at 100% battery, right? We can make her charge. So where did we do that before? Let's undo this. Let's undo this part. So let's change this back to what we had at the beginning, actually. And so the only part we have is if the battery is 0, right, then we plug it in. So we've sort of just reset everything. And that's because we're going to try a different solution. And a different solution using logic gates. Okay, so we want to see like if something, then Aki is charging, right? Let's find out when we should charge Aki. Obviously, we want to charge Aki only if she's plugged in, right? So instead of saying, we're sort of replacing if charging equals plugged in. Plugged in. So we're getting rid of this line and we're gonna do it in another way. So hopefully this isn't like confusing anyone. I hope I haven't lost anyone. We've basically just reset everything. So you can ignore anything that happened before. So when do we want Aki to charge? So the condition would be, well, Aki would need to be plugged in, right? So it'd be plugged in equals true. What other condition is there? We also said that we don't want to charge her when her battery is 100, right? So when battery equals 100. And I finally got the word right there this time. And so we can write that like this, right? If plugged in equals true. And we already said we can sort of merge this into one, because plugged in is either true or not. So if plugged in, right, is charging equals true. The second part of this condition is if battery equals 100, 199, 100, then is charging equals true. And we also said we want to be able to combine these, right? Because we're doing the same action this time. Do you remember before when we combined the two conditions? It was because both of the conditions were the same, right? Remember, it was like if battery equals, both of them were using this, right? And doing two different things. Now we want to do the same thing with two different conditions. So what do? Well, we combine this, right? Now, obviously, this condition doesn't completely make sense because we want both of these things to be true at the same time before we make Aki charge. Because Aki can't charge just because her battery, is not 100, is what we should say. Is not 100. So we shouldn't charge Aki if her battery is not 100. Sorry, we shouldn't charge Aki if her battery is 100. But we should charge her if her battery is not 100. That's the right way to say it. All right. But we want both of these to be true at the same time, right? So we want to charge her if she's plugged in. So we can combine these two. We can say if she's plugged in and her battery is not 100, then charging equals true, right? This is another way to do like what we just did before in different words. And also using an and logic gate and a not. This is a not equals, which is a little bit different. But yeah, this is very similar. And also we can do things like check. So like we can do basically the exclamation point is just saying the opposite of something. So if we do like if not plugged in, right? If not plugged in, we can say is charging is not is false, is not true. False is the same as not true. So there are so many different ways that we can type this, all using like the same simple blocks. Wouldn't charging be full if battery is 100? Yeah, this is saying if battery is 100, or if battery is not 100, keep charging. Because is charging is true, is only true if battery is not 100. Oh, sorry, I didn't realize that there was a if plugged in and battery does not equal 100, is charging equals true. Yeah, that's exactly right. Yeah, I just saw Shad's code. But yeah, that's exactly what it should be. So you're asking, wouldn't charging be full if the battery is 100? So the charge would be full if battery is 100, but we want to take the charging off when it's 100, right? So when battery is not 100, we should have is charging is true. And you can actually test this. Like at 100, we have to go to 0 first to put the plug in. Then go to 100. We actually want this to be false when it is 100. So we actually need to add an else statement, right? And else means everything that's not in the conditions before it, then do this. Do everything in the else block. This is a new block. I don't think we've learned else yet. Yeah, battery does not equal 100 means battery not at 100. Hopefully that was clear. Anything with an exclamation mark means not. So is charging equals false, right? This is another way we can write what we did before, where we combined the if battery equals 100 lines. So this way, it's saying if Aki is plugged in and battery is not 100. That's what this line is saying. Battery is not 100, right? Which is now, but I'm not plugged in right now. So let's put it at 0. That means I am plugged in and I'm charging because the battery is not at 100. But if we put it to 100, you can see that we are plugged in, so this is true. But battery is 100, so charging is false. So else actually needs to have if conditions in front of it, but you don't need to put anything here, right? It's not like an else if where you actually need to write a condition. Else just covers like everything. Basically, like anything before else will be their own separate conditions. And then else is saying anything that's not those conditions, I'm like a catch-all for it, right? So I think a better way to show it would probably be question 6 over here. So I'm going to skip over 5 real quick, just so we can work through this a little. But yeah, so you can have ifs, else, ifs, and elses all in the same block. Kind of like this. If, else if. You have more else ifs. You can have any number of else ifs, as long as the conditions make sense. And then at the very end, you can actually change the last else if to an else. Like if you had 3 else ifs here, say you had like variable x equals 0, right? If you have variable x equals 0, you can check if x equals 1, else if x equals 2, or if x equals 3. Like these are just example conditions, right? Else if x equals 4, right? So you can do this. And if you know that x can only be 1, 2, 3, or 4, you can actually take out this last one and just have it as like the default. You can take out this condition and have else. But remember that else encompasses everything. So if x is like 5 or 6 or 7, it's going to do whatever is over here. Yeah, if all if conditions fail, else will execute. Hopefully that makes sense. Okay, let's actually put that to use, right? So you'll notice that in our code right now, the indicator is actually always red. But that's not what we want, right? That's not what we want. We actually want the indicator to be green or yellow, depending on what the battery percentage is. Can you do an if without else? Yes. That's what we started doing. We have an if without else here. So if doesn't need anything else. That's a weird way to word it. You can have a standalone if statement. You can't have a standalone else if statement. Like if none of these existed, right? If none of these existed, I can't just put else if something, because the computer will wonder, well, what comes before else, right? Like what condition is there to be else of? And you can't just put else either. But you can put just an if. Just an if works. You can also have, you don't have to help else if with else. Like you can have just an if with an else, or just an if with an is else. It's like a tongue twister. Or you can have any combination of them, as long as the first if exists. But you don't need any of them. you can just have it alone. So hopefully that makes sense to everyone. So let's undo this. And actually you'll notice that since we changed it to this solution, we still haven't done the part where we take the plug off yet. So we actually need to do that first. So what we can actually do is, so we have if battery equals 0, plugged in equals true, we can just add it over here. Else if battery equals 100, we're basically just adding back in the logic that we deleted from before because we did an alternative solution. So this is just another way to think about it. You tried Shad the Hedgehog's line and it didn't work. What part of it is not working? What's it doing instead? So think about it that way. And if it's not working, first start with one part of the condition before the and statement, right? Check that that works first using console.log to print out what the values actually are, right? And that's an easy way to check. If you're still lost there, if you try debugging and you just can't figure it out, drop your code into the Discord, and we can take a look at it afterwards. But yeah. So, where were we? Right. We want to take off the plug here. Plugged in equals false. So this is just another way of doing what we did before, right? So this is just saying that if the battery is 100, we take off the plug. So if it's 0, we put on the plug and we charge. That's what this line does. This block deals with the charging. And this block deals with the plug, right? Yes. And if we go to 100, it takes off the plug and it takes off the charging. And we can actually change this back to is charging equals plugged in. These are logically equivalent. They're the exact same thing. And you'll notice that if I take it off, I just replaced it with one line, right? Let me show you. We just replaced this whole if statement with one line. That's what simplifying your logic is like. It saves you so much work. Like in the chat, I see that Newbie Gaming, you're saying like this line doesn't work. Like this line is obviously a little bit more of a complex if statement, right? So if we simplify our logic, we don't even need to have the possibility of making these types of mistakes. Now, obviously you should learn what's wrong with it, just because we're learning about if statements right now. It's going to be useful for you to practice. But in the context of this code, like we want to make as few mistakes as possible. And as few mistakes as possible means that as simple as the logic can be. So we can just do is charging equals plugged in. Because we already know that that condition is sort of the same as saying if plugged in and battery is not 100. Because, okay, here, let's break it down. Oh, you didn't put the else? Okay, perfect. That makes sense, yeah. Shad was just giving like a snippet of code. So you do need the else statement to make it work. But yeah, let's break this down and see why we can replace this with this, right? Now, why is that? Let's take a look. Here, I'll put this here just so you can see it, because these two are logically equivalent. They do exactly the same thing, so we can leave them both in and it'll still work because nothing has changed, right? Because it's setting is charging and then it's setting is charging the same way again. And so let's take a look at this. If plugged in, right? If plugged in. That's basically what this is saying. This is basically saying if plugged in, charging is true. Otherwise, charging is false, right? That's what this line is saying. Now, why were we able to get rid of and battery is not 100? Well, that's because if we look at this statement before, you'll see that plugged in is always false if battery is 100, right? So that already means this line is not useful anymore. So even if I took this out here, if I take this out, we can simplify it step by step. We can simplify that line, right? This condition, plugged in and battery is not 100, to just plugged in. Because we already know that we're not going to be plugged in if the battery is 100. So we don't need to worry about whether or not we're charging at 100 because we'll never be plugged in anyway. And we need to be plugged in to be charging. And so let's take a look at that. At 0, we're charging and we have the plug-in. At 100, we don't have either, which is exactly the same thing, right? We haven't changed any of the behavior, which is exactly what we're trying to do. We've only simplified the code. So the computer just has to do less and we have to read less. Now this is equivalent to this, right? Because let's take a look. Is charging equals plugged in? If plugged in is true, right? If plugged in is true, that's what this line is saying, then is charging is true, right? So plugged in is true, then is charging is true. Else, so else means not plugged in, right? That's another way to write it because plugged in can either be true or false. Remember the logic tables that we used? It's sort of like that. Plugged in can only be true or false. True or false, right? It can only be true or false. And so if plugged in is true, we can add is charging too. So if it helps you, you can sort of make a logic table like this. If plugged in is true, then what's this charging? Well, it's this, right? We set it to true. T. And if, else if plugged in is not true, right? Because we know plugged in has to be true or false. So we can just write this as else because plugged in can't be anything else. Plugged in is either true. This is plugged in as true. Else plugged in is false, right? That's basically what these two are saying. And the reason we don't need an else if for this is it saves us some typing. It saves us some typing because we don't actually need the computer to check if plugged in is false because we already know that if plugged in is not true, like if this condition doesn't trigger, then it has to be false. Plugged in has to be false. And so if plugged in is false, then charging is false, right? So these two are logically equivalent. That's why we can set is charging to plugged in and remove this entire if block. Hopefully I haven't lost anyone there. I know that doing these simplifications, it takes a little bit of getting used to. If it doesn't make sense right now while you're thinking about it, just write down every single possibility of the condition that you're writing. Do it like in a table like I did or however you like to think about it, and it'll make a lot more sense that way, right? And then just check your code each time you do anything big. Check it often. Make sure that everything still functions the way you intended it to. Cool. So let's move on to the next question, right? I guess we can do 5. Let's do 5 just to practice a bit more in the if-else statements. So just to be safe, Aki should be charged before her battery is empty, right? So before battery is 0. So using an if statement, plug in Aki. So that's the action. We know that's the action. Plug in Aki, right? Plug in Aki. And the condition is when her battery is under 20. And make sure she's charging when she's plugged in. So this will already make sure we're charging when we're plugged in, but let's move it to the very bottom because we always want this to happen at the end. Because think about like if we changed plugged in after this, right? If we change it after this, is charging doesn't know that it's changed. The computer still thinks is charging is whatever plugged in was at this time. So like for example, this means that charging will not work properly with plugged in. Here, we can do true too, right? So it'll always be one behind. So we want is charging to be set at the very end, after we're done with putting in the value to plugged in. You like to log before and after changing stuff to visually understand. Yes, that's a really good idea. That's a good idea. What he means by that is before this if statement, we log plugged in is, and we can write this in like human language if we want. Is Aki plugged in? And you can type plugged in. And then we can do it again after whatever we do, right? And this way, like, as these are changing here, and I'll write before, before, and also after here, right? So before and after. So you can tell that this is what plugged in, the value of plugged in is before this if statement happens. And this is what it is after. And let's change it to 0 to take a look, right? Was Aki plugged in before? No. But after this if statement was executed, yes, Aki is plugged in. So that's a really good way to sort of figure out why your code isn't working and what it's actually doing. That's a really good way to go about it. But yeah, that's like a really good practice to get into, is to print out everything or print out things that will help you investigate and find out like what is wrong, and to understand what your code is doing and what data it's working on, because those are really important in code, right? So we can start doing 5. We've taken out the action and the condition, right? When her battery is under 20. And this is also part of the action. And charge Aki, right? So this will very much look like math to you. Here are the actual comparators that you can use. So you've seen equal to before, right? Yeah, not too many console.log statements. If you have too many, sometimes it clutters it up and it makes it harder for you to be able to read it. But just put enough that you have the information that you need to go off of. But yeah, that's a really good way to go about it. So let's go to this. These are the comparators. So we've already done equal to, right? We're experts in that now. And the other ones are all exactly like the ones from math, pretty much. So there's greater than, there's greater than or equal to, right? And these are exactly what they sound like. Hopefully these are all making sense to everyone, because these are just math, right? Like very basic comparators. And there's less than or equal to. So what's this one asking us? This one is asking us when her battery is under 20, which means when her battery is less than 20, right? That's kind of how we think about it. We're just replacing it with the symbol. This means less than. An easy way to remember this, all the way from elementary school, I think, what I learned was the comparator sign is an alligator, and the alligator wants to eat whatever is bigger. So if the battery is smaller than 20, the alligator wants to eat 20, right? Say the battery is like 19 or 0 or any number in between that. Right? This condition is just saying battery is between 0 to 19. Yeah. And 0 to 19 doesn't look very delicious, apparently. Only 20 does. 20 and above, but 20 is the one that we settled on. So let's set up our if condition again. Like, this is probably going to look pretty familiar to you right now, right? So we can say if battery is less than 20, right? And whatever we do here to plugged in will replace this. So you could erase this if you want or leave it there as reference. But whatever value we set plugged into here will overwrite this because it's happening after. Right? Anything that comes after will be the final value. The last instance of this will be the only thing that matters. Right? So if I said, for example, if I said plugged in equals false and is charging equals false. I can't type today. My hands are too cold. If I do that, right, since it's the last thing that happens in the code, we'll never charge and we'll never be plugged in, no matter what's in front of it. Regardless of anything here, if it's the last thing that you're setting, it'll just be whatever you set it to there. That's how this code works. It's very sequential, right? It goes from top to bottom. That's how the computer reads it too. That's how the computer executes on it. And so let's look at this condition. When her battery is less than 20, right? If battery is less than 20. We don't want less than or equal to 20, right? Because we only want it to be 0 to 19. It says less than. The question was less than. Less than. My hands are actually really stiff right now because they're very cold. Or maybe an alligator ate them. One of the two. But yeah, we want less than. If we really wanted to use less than or equal to, this is actually equivalent to less than or equal to 19. So you could say this, but why not just use the wording that the question gave us? It's easier that way. And 20 looks a little easier to look at, right? It's a nice round number. So if battery is less than 20, well, what do we want to do with it? We want to plug Aki in and charge Aki, right? So we do the same thing as before, plugged in equals true. We're basically just replacing this, if that's how you want to think about it. Else, if battery equals 100, then plugged in equals false. And make sure your case sensitivity matters. Make sure you're typing it exactly how you told the computer you were gonna call it. Yes, if hands cold, type poorly equals true. That's me. My hands are actually icicles right now. That's what happens when your body is made of metal. But yeah, you'll notice this is almost exactly the same block, right? The only thing we've changed is the threshold, like the condition. So we could actually just remove this whole thing. And let's see what it does, right? So let's set it to, here, let's go down slowly. So we're going down, and then we're going to go down to 20, right? At 20, nothing's happened so far, right? Because it's less than 20. That's when it triggers. What happens when we go to 19? There we go. We're plugged in and charging. That's what we want. And you'll remember, see, we didn't set anything for charging, but we still have this line from before, and we kept it at the bottom. And that's setting it to charge whenever Aki is plugged in. And that's the line that's doing it, right? And then this is going to have the same behavior as before. Like, you can still go down to 0 and nothing will change from it. Once it hits 20, it's still charging because we don't take off the plug until battery is 100, right? That's what we said. Obviously, like, if if you're charging your phone or anything else, you don't want to just take it off when it's at 20. You want it to charge fully. So when it's 99, you don't want to take it off. When it's 100, we take it off and we're no longer charging. And that's how we're doing it, right? So what we basically did was we just replaced all that logic with this logic. So we've simplified it, and we've made it so that the threshold isn't 0. It's around 20. Like, we obviously don't want the battery to die completely before we start charging it. That's it's just more convenient that way. All right. So that's question 5, right? Let's go down to question 6. So what do we actually want to do here in question 6? Well, this is where the colors come in, right? So using if, else if, and else statements, let's change the color, okay? So let's see, 0 to 19, we already know is less than 20, right? So let's write this out. This means battery is less than 20. Or you can say battery is less than or equal to 19. Because we already know that the minimum for battery is 0. We don't need to check this side of the threshold, right? We only need to check one side because of the constraint. Like, we can't go lower than 0. If we could go lower than 0, then you have to check it, right? So it would be like this. Battery is greater than 0 and battery is less than 20. And the way we write and, remember, is like this. So it'd be like that if 0 weren't constrained, right? And the other way to write that was what I just showed you. If battery, oh, sorry, this should be greater than or equal to, because battery can be equal to 0, right? So this one would always be the same. Or you could put greater than 1, or sorry, not greater than -1, right? These two are equivalent. You can do any combination of these. And battery is less than or equal to 19, right? So this means battery from 0 to 19. And this also means battery from 0 to 19. So there are a lot of different ways you can write it. That's how coding is. Like, it's really different approaches to problem solving. And sometimes there are better ways to do things, and sometimes there are worse ways to do things. For this, it doesn't really matter. Okay, the computer, either way, like whether it checks if it's greater than 0 or greater than -1, it doesn't care. But who does care? Whoever's reading your code will care. So write whatever makes sense to you for greater than or equal to ranges, right? And these two are interchangeable. Like, you can move this here, you can move this here. It's greater than -1. It doesn't matter, right? As long as this is one condition and this is another condition. Hopefully that's making sense to everyone. Okay, how else can we write? What about yellow, right? For yellow, we can say battery is greater than, let's use greater than first, okay? Let's use greater than 19, right? 20 is greater than 19. The first number up from 19 is 20, right? So if a number is greater than 19, it has to start from 20. And battery is less than 50, right? Because we still want 40 in this range. We want 20 to 40, 49, I mean. And so the first number lower than 50 is 49. So this is acceptable. What's another way to write it? Let's use greater than or equal to and less than or equal to. So this is battery is greater than or equal to 20. This way is a little bit easier to see because you're actually like using the number that's here, right? And battery is, let's give them some space so we can line them up. Battery is less than or equal to 49. Right? These two are equivalent. These two are saying the exact same thing, these two lines. And so are these two lines. And you can do the same thing for green. Let's do it as an exercise. We wouldn't normally write all this out, and I'm going to show you how to like write this in an if else statement, but let's do this as an exercise, just so it's in our heads, like how these ranges sort of work and how to constrain numbers. So we want 50 to 100. So that means battery is greater than 49, right? And battery is less than 101. Kind of like that. The other way to write it is battery is greater than or equal to 50, and battery is less than or equal to 100. There we go. And that's all of our ranges, right? Now let's translate that. Let's translate that to here. Let's translate all of this into an if-else statement. Let's move this down here too, so we can see it. Okay, let's see. Let's translate it very literally right now, okay? We're gonna type it all out, and then we're gonna make our optimizations. So let's start with red, yeah? We'll start with the lowest. It doesn't matter where you start from, but normally it makes sense to either go like ascending or descending. So start from lowest to highest or highest to lowest, whichever you want. But as long as there's like a logical progression, right? It doesn't actually matter since we're constraining it like this, but you'll see why it matters in a second, right? So we can just take one of these. We can do battery is greater than or equal to 0. And battery is less than 20, right? But remember I said battery has to be above 0 already. We already constrained that. Like the code handles it for you. I've already written that for you. So we can just say battery is less than 20, right? Let's keep this in for now, and then we can optimize it in a bit. And then we'll put color equals red here, right? Whoa. Color equals red. That's what we want. Red is 0 to 19, right? That's what we've just done. Let's do an else if for the yellow, right? For the yellow, we want battery is greater than 19 and battery is less than 50, right? We can use any combination of these. It doesn't matter. As long as we use one of them, that's correct. Okay, so now that we have that, we can do color equals yellow. And then let's do else if battery is greater than or equal to 50. And you'll notice I'm doing this very inconsistently. I'm just picking them at random from here. And that's just to drill in the fact that they're exactly the same. It doesn't matter what they are. Right, so we can do this. And then color equals green. And then we can just check that this is right. So it's green if it's 50 to 100. Yep, that looks right. If it's 49 and below, up to 20, it's like this. We can put it to like 20. And then underneath is red, right? Right, so all our logic is correct, but this is really ugly, isn't it? We don't need all this. We need none of this. So remember we said battery can't be less than 0. So we can already get rid of this, right? We can get rid of this. Simplify it into just battery is less than 20. And this means the same thing because we know that battery has to be above 0. And we know that battery can't be above 100. Yes, it's very, very ugly, but we're about to fix it. Yeah, we know that battery can't be above 100. So that's gone too. Delete. But there's more we can do. There's more. Remember how we said, right? We can use else statements to encompass like all of the remaining cases. Every single remaining case we can encompass. So let's take a look. This gives us from 0 to 19, right? This is 0 to 19. And then what this gives us is 20 to 49, right? So combined together, these two give you all the way from 0 to 49. And this is giving you 50 to 100, right? But if this is already giving you 0 to 49, 50 to 100 is everything that's left over. So we take all this and we can replace it with an else. Yes, else on green. There you go. Else on green. You got it. So else is just 50 to 100 because we know that we can't go above 100, right? Remember we tried. We can't go 101. It puts us right back at 100. You can't charge past 100. Or hopefully you can't charge past 100. At least not for my battery. But nice. We've already simplified this. What about this? This looks really ugly too. Can we simplify this a little bit more? Notice that we use an else if statement, right? Like if we did this, if we made these all if statements, then we would need this. But since we use an else if statement, what does the computer do? The computer checks, is the battery less than 20? And then if it's yes, then it skips everything here, right? It skips all the else if, it skips the else. So 0 to 19 is already covered. That means by the time the computer reaches this, it can't possibly be under 19, right? It can't possibly be. Or, yeah. So we can actually remove this part. There we go. Now it looks a lot cleaner, right? If battery is less than 20, so all the way from 0 to 19, if the computer sees this, it'll change the color to red, right? We can see that here. 0 to 19. Then for yellow, 20 to 49, right? 20 all the way to 49, it's yellow. Then for green, everything from green up is from 50 up is 100. Yay! That looks so much better. and it's sort of like a mini game too within the coding, right? Like obviously like some of this is really fun to do. It's like it's so satisfying to take out the statements that are unnecessary and make them into something that's really concise and like really simple. There's actually like a game that people play. It's called Code Golf, and it's based on making the shortest code possible. So people will post questions for what your program should do, and then people who play Code Golf will measure their program by the number of characters they have to use. And they do some really crazy things because there are languages that are created for Code Golf. So like one character equals like a bunch of different commands at once. And so Code Golf is really interesting in that way because people make a game out of like making the shortest code they can. And I guess that's kind of what we're doing too on like a much smaller scale. But yeah, it looks a lot better now and it's doing what we want it to do, right? So hopefully everyone's code is working like this. If not, don't worry. It might take you a bit longer just to debug or to wrap your mind around these conditions. Just take a good look at what your conditions are. And if in doubt, always just console.log, print something out, you know? Cool. So now that we're done that, what else can we learn? There's one last thing that I wanted to teach you guys. And they're called switch blocks. I know that I said we're gonna learn if, else if, and else statements today, but a switch is very similar. It's not used as often in programming, but for the cases where you can use it, it's actually really nice. All right, so for switch blocks, they look kind of like if statements, but they're a little bit different, right? So it kind of looks like this. Switch something, and then you have like different cases, right? So like case something, case something. This won't make sense yet, but I'll fill it in for you. Yeah, print means output to console, like print to here. This is your console, if you can see it. Like this thing is your browser console. That's what print means. The computer is just printing something onto the screen. All right, so what does switch do? Switch means you can put a variable or sometimes like conditions here, but we're gonna do a switch on battery, right? We're gonna send out indicator messages at 0, at 50, and at 100, right? So these are the conditions. What is the action? The action is send out indicator messages. Action, right? That's, there needs to be spaces there. That's action. Okay, so if we do a switch on battery, actually before we do that, let's write that out as an if statement first. Just quickly so we remember how to do it, right? So if battery is at 0, right? What do we use for the indicator message? Let's take a look. Battery indicator message, right? Remember we did like a little test with this, right? And then whatever you type here shows up, right? So now that we know what to use, it's called indicator, variable indicator. Let's set it to something. So at 0, we want it to be empty, right? So let's just write empty there. Anything within the quotes is what the computer will write. Right, so we refresh it, it's 50, let's go to 0. There we go, now it shows that it's empty, right? But now it always shows it's empty. What gives? That's because we don't ever clear it. So let's do an else, right? Else indicator equals empty string. So we put nothing in here. So now when we go to 0, it shows empty, but when we go up, it doesn't. So it only shows empty at 0. And that's what we want. Remember, because this is the condition, and else covers everything that's not in the conditions. Everything else. That means 0 is empty, and then 1 to 100. 1 to 100 is nothing, right? That's what this means right now. Now, how do we add these? How do we add 50 and 100? Well, we add them through else ifs, right? We just add more conditions. Else if something. Where is my curly brace? It doesn't like that. I was hoping Sublime would autocomplete that. But since it was on the same line, it didn't want to. That's okay. So else if, it'll look very much the same. Else if the battery equals 50, right? We do the same thing here. We just copy this over. Whoa. Sorry, I'm on a new keyboard, so everything's just a little bit wackier than I'm used to. My keyboard actually has the control and shift swapped around. So my control is where the caps lock is, and then I just don't have a caps lock, which is fine because I don't use it, but it makes shortcuts a little bit confusing sometimes. But now we have if battery equals 50, right? What do we want when it's 50? We want it to say halfway. So let's do that. And let's test it out. Halfway. There we go. And then we want to make sure that everything else is still fine. Yep. No halfway here, no halfway here. What about 0? 0 is fine too. Nice. So let's just keep adding this, right? Let's keep adding another one for 100. And 100 should just say full, right? And we can just check that real quick. There we go. So it shows at 100, at 50, and at 0, and nothing else. And that's what this says. Now, how do we use a switch statement to write this? How do we do that? Well, we can take battery, which is the variable that's changing here, right? Like see throughout all of these, battery is the thing that's changing throughout the conditions. That's what's triggering the conditions. So we're going to say switch on battery. Battery is going to become the switch. And then these are cases. So think of these as our if statements within the switch, right? So case, battery is 0, right? This means battery equals 0. It's the same meaning. That's what this means, right? If battery equals 0, we can just copy this over, right? Oh. Indicator equals empty. And then we'll do the same thing for the other two. If case equals 50, battery equals halfway. And in the case that battery equals 100, indicator is full. Hopefully that makes sense to everyone. I know this is new syntax. It's a new block that folks haven't seen before. But this is what it means. And between each of these, we actually need something called a break. You don't actually need to know too much what this does, but this basically just ends this statement. It's telling you that this condition's already done. Because otherwise it actually, what it does is it does this, but then it keeps going if you don't break it. And that's like another way to use switch statements, but we don't really need to get into it. There are like other uses for it, but this is the most common one for translating like if statements in the case where you have very distinct sort of stages in which you would have things happen, right? So right now we have 50, 0, and 100. But what's missing? What's missing? What's missing here? Oh, let's get rid of this so it's not affecting our thing. Right? So it has this. But what's missing here? Everything that's not 0, 50, or 100 doesn't have a case that's supported for this right now, right? So what can we use in place of the else? I see someone already wrote it in chat. That's right. Default. There's a default case. You don't need to write case before this one because they sort of simplified it for you. And the default, what we want it to be is indicator equals nothing, right? That's what this is. Everything else. So it's the same as this. This is everything else. This is 100. This is 50. This is 0. These two statements mean exactly the same thing. Let's test it. Let's test it. We'll comment this out and test this. So 50 is halfway. Make sure nothing else is. Yeah. 0, let's test that. It's empty. And 100 is full. Yay. And so that's the program. That's our first game. We can successfully charge Aquino. And we have the colors to prove it. and the symbols to prove it too. Cool. And there is a little bonus question here of removing or commenting out all the test code that no longer does anything. So you guys can do that on your own time for your code. And yeah. Hopefully this was easy to follow along. I know that we went really in depth into like a lot of these things. But yeah, that's if statements for you. If statements and switch statements. And also, you'll notice that you can finally apply like all your logic gate knowledge from last week, right? Now you know what these are for. They're to put together statements, right? Yeah. And I think that's probably a really good place to end the stream here. That's sort of a walkthrough of this game. I'm going to have a different one for you probably next week. Well, not probably. Yes, I'll have one for you next week, in which we'll learn about loops. So that's going to be really fun. Loops is where things get really interesting with programming, because the whole reason you have the computer do things is because the volume of things that the computer can do is a lot more than what you can do. And so once you get into loops, you can start making games that are like actually games. You know, like this is obviously just like a fun little simulation, but it's not like a game. But we're gonna keep making little games like this until we reach like something that's like the caliber of like a bigger game, you know. One shouldn't be afraid of loops, no. Especially now that you know conditions. So conditions are actually a really big part of loops. That's basically like all loops are. It's using conditions to tell the computer when to do things and how many times to do things. So it'll be very similar to this. So don't be scared of it. You basically already have like all the knowledge you need for it. Now we just need to like apply it and practice loops. But yeah, we'll be putting it together next week into something that makes sense as loops. But yeah, make sure to join the Discord if you have any extra questions or if you need help with your code. If you want the solutions, if you go to the GitHub, there's actually a pull request. If you go to like, here, I can actually show you. There's a pull request tab here. And I actually have a branch showing you like if you go into files changed, you can see like one example solution of like all of these questions. So this is like 3. Yeah, I wrote these earlier, but it should be one of the solutions. I know that we did a little bit of a different solution here today. Actually, we did 2 of them, so it's pretty good coverage. If your code looks different from this, don't worry. Like, obviously, you can get the same answer through different ways. It's kind of similar to like math or anything else. So if your code looks different, but it works exactly how like it's described in here, then it's fine, right? But this is just an example for you to look at in case you're stuck. If you are stuck though, I would suggest like trying to fix your code first before looking at this. And like you can take a look at this like at the very end just to see like what there is. But I would definitely recommend like just practice it yourself. Try to work your way through this. If you find any like typos or mistakes, let me know. I'll fix it right up. But other than that, hopefully you guys enjoyed this lesson. So it'll take up by 1 until full, which means you can make it lose battery on its own. Yeah, I can definitely do that. I'll think of like what fun way to introduce loops and what we can use them for. And that might actually be a really good idea. So I'll see you guys probably in office hours actually on Saturday, 7 p.m. PST, 10 p.m. EST. And the next lesson will be on Wednesday, same time. I don't know what I'm going to do for the office lesson or the office hours yet. I know we played Minecraft last time. I'm hoping we can get a server set up by then. And then maybe we can see some builds. But if not, we'll just chill out a bit with Jay. We'll answer some of your questions. Maybe go over more of this if anyone wants us to. But yeah, hopefully everyone had fun. Happy Wednesday, everyone. This is Aki signing off. I'll catch you guys on Saturday.